Hi, my name is Garrett Edmondson, and welcome to another of my videos in my series of videos about constructing a data warehouse with Microsoft SQL Server. This video will concentrate on Microsoft's MPP solution, or Massive Parallel Processing Solution, which is called Parallel Data Warehouse, or PDW for short. If you have not already done so, I would highly recommend that you go back and watch the previous videos to this one in order so that you have a thorough understanding of some of the things that I will be mentioning. Because I will only cover PDW in a short manner and emphasize those things which would be important to understand from an SMP perspective, and some things which differ from SMP and MPP or PDW. As review, this is a slide from the first presentation where I explained the importance of having a balanced architecture and having the ability for your data warehouse hardware being able to deliver consistent throughput in terms of megabytes or gigabytes per second from storage where the data resides on the right hand side here all the way through to where SQL Server execution is occurring in the processor and cache are. And I talk in a little bit of detail in that video about all the I/O components and the importance of testing and configuring and buying the proper I/O components. I want to emphasize that that is a time-consuming and can be a costly process, but is very important to ensure that you have reliable, predictable performance of your data warehouse as your data volumes and queries and number of users increase. Unfortunately, with this type of configuration, the ability to scale is limited to a kind of a scale-up approach, meaning that if you want to have better throughput, let's say in this example I have 2 gigabytes of throughput, if I want to have 4 gigabytes of throughput, it would mean in most instances obsoleting the hardware investment that I already made and all the work that I went through to fine-tune all these I/O components that connect my SQL Server to its storage. And so that's really kind of the only approach there is to SMP, or symmetrical multiprocessing. The I/O interfaces need to be switched out because typically you buy I/O interfaces for a specific throughput, and if ever that needs to be increased, then all those procurement, testing, and configuration needs to be done again, and that can take a long time to do. So now jumping back to this slide, SMP versus MPP, I would like to focus on this graphic which Rob Kerr, SQL Server MPP with Blue Granite put together. I think this is a great graphic. Now there is no numbers behind this graphic, but I think it communicates the idea of scaling an SMP versus MPP and how these things are scaled. So on one axis here, you have cost, or how much it costs to scale, and then on performance, as performance to get better performance, what that is. And so SMP here is the scale up approach that's represented in green. Initially, to buy an SMP box, let's say that gets 500 or 1 gigabyte of throughput, doesn't cost very much. But as you get more and more powerful boxes and you get close to the top end of whatever your hardware vendor you're able to buy from, getting the latest generation of processors or something like that, your costs can rise significantly. And this is the scale-up approach. And it's the only kind of approach that's available with SMP. Now with MPP, it's much more simpler because you have a base unit, which is essentially a single MPP appliance that is architected specifically for data warehouse specific workloads. And as you need to scale or increase your throughput or increase your performance of your data warehouse, the only thing you need to do is buy more of those base appliances, and they are connected together in such a way that they have the data distributed across them, and so it's the combined throughput of all the base units in your in your PDW that gives you the horsepower or the performance of that total PDW solution. And so its cost curve becomes more linear because it's much more predictable. You simply add more of the same base unit, and the base units have a standard cost, and so the cost becomes more linear in relationship to performance. However, in S&P, it tends to mimic some sort of exponential growth in cost as performance increases, because when you get close to the very top, to get the latest greatest generation of S&P servers is usually very expensive from your hardware vendor. These base units are typically mid-range type, small to mid-range type appliances. So that is kind of the general thing to keep in mind here, and really the compelling reason to go to MPP in many cases is for this reason, for this scale out approach. Now, as this graphic illustrates, there is a point that, and this graphic doesn't have any numbers behind it, but there is a point at which S&P is a better cost in terms of cost and performance. That is, it's a cheaper alternative or more economical alternative. But as you need to scale, there will be a point where these two cross, and MPP, or Parallel Data Warehouse, will be a much more economical and efficient approach to scaling your data warehouse. And this point is sometimes hard to determine, and it requires a lot more analysis, but there is a point at which this does occur. And so that's why if you read the Fast Track documentation produced by Microsoft, you will see those Fast Track appliances, and there's usually a couple different levels of Fast Track appliances. For instance, Dell has a Quick Start Data Warehouse, a Quick Start Data Warehouse 1000 and a 2000. You might actually ask yourself, why doesn't Dell have a Quick Start 3000, let's say, for example? Well, because really at that point you've now becomes more economical to switch to an MPP type solution, a scale out solution. And again, how do you know which one you need to do? Well, it depends on the performance you're looking for, and performance is throughput. And so I have the previous videos describe in great detail what that throughput means, megabytes per second, and how to measure that for your queries, so you can have expected response times that are consistent. So in other words, it depends on your query profiles. And if you've not watched those videos, I highly recommend that you do so. So with MPP, the last thing is you keep all your hardware investment. You buy one MPP base unit, and then you can buy subsequent base units at the same price, and you keep all your hardware investment. So this is an example of HP. Now, HP and Dell both provide, as of the making of this video, both provide Parallel Data Warehouse hardware solutions, and there's small differences between them, but I'm not going to go into this. I just want to give you a basic idea of what this entails. So every PDW will have some InfiniBand controllers and Ethernet controllers and things like that for basic networking. Now, it'll come as an appliance in a rack. You'll have a control node and a failover node. I'll get a little bit more into detail about that. And then you have your base unit here. And for HP, you have two compute nodes with a JBOD, or just a bunch of disks. And the name implies, for just a bunch of disks, that they are just a bunch of disks. The RAID and those kind of things are virtualized in the newer version of Microsoft Windows Server. It has the ability with disk spaces and things like that to virtualize RAID levels on the JBOD. So you don't need any RAID controllers or those kind of things. Windows Server takes care of that. So on your compute nodes, as you can see, these are 1U units, 16 cores, and here's your JBOD with 1 terabyte drives, and you can get different sized terabyte drives depending on your space requirements. And those are over on the right hand side. But as you see, this is the base unit. So this is the starting point of MPP for an HP PDW. Now, if this doesn't give you the throughput or the performance that you need, then you can either up front or later on down the road purchase additional base units. And that's what's here happened here. So now this client has now upgraded to and bought 3 more base units. So they've filled up this rack. So this is an entire rack with 4 base units, and the base units again are identical in terms of their hardware, and you still use base unit number 1 here, and you use the additional scale units. So and they are identical. One small thing to consider here, and I'm not going to go much into PDW. I have worked on several PDW POCs and implementations, but there's great videos out there, and I'll have links at the bottom of this video to probably some good videos from TechEd and other places about how to get into the details of PDW. But I just wanted to give you an overview of this and how this kind of complements the things I've been talking about. There is one small space here for an ETL server. In a previous version of PDW, this was the landing zone, but now this will be supplied by the customer. So, and that is a full rack solution. And again, you can buy your initially just 1 base unit, or 1 base unit plus as many scale units as you need to get the correct performance. Now, if you still don't have the performance you need, and you need more performance, then of course this is the additional step in the scale out methodology here. Let's say I have 1 full rack with those 4 base units, well, 1 base unit plus 3 scale units. Now, if I wanted to scale my data warehouse even more, then all I have to do is buy additional racks. So you just add capacity as it indicated here with scale units, and you can add entire racks. So each one of these racks represents 4 of those units together, each one having 2, in HP's case, 2 actual servers. So 2 SQL Server instances per. And as the graphic indicates here, that you can scale to the petabytes range, 5 petabytes. This is a very economical and simple way of scaling out your data warehouse. As your company, as your data grows, you can have the security and peace of mind to know that your solution, your data warehouse, will be able to scale appropriately to meet those needs without having to go through the complex process of having to re-architect all the hardware, throw away and re-architect a new set of hardware. You just add to the additional existing hardware more scale units or more racks as needed. So that concludes that. I'm not going to go much into the backup strategies or anything like that. So now that I've given you that kind of basic introduction to PDW and its hardware and scale out, and how PDW can scale out from a 1 base unit solution to multiple units within the same rack, and then to multiple racks, I want to go back and drill down a little bit into what all these servers represent, and a little bit about what's running on each one of these servers. So in the graphic that I have presented right now, I have what is sometimes, and I don't think they're going to use this terminology much longer, but what is referred to as a quarter rack, or a PDW with 1 base unit. And the base unit has 2 compute nodes or compute servers here. And so starting at the top, I have my switches for InfiniBand and Ethernet, and then I have what's called the control server. So the control node, or the control server, is it has the kind of the brains of of PDW on it. It has the various services installed that allow PDW to really make use of all the underlying compute nodes. All the compute nodes are just, for the most part, regular instances of SQL Server 2012 in this, as of the recording of this video. So each compute node has an instance of SQL Server 2012 installed on it, and there's nothing particularly special about it. It's just a regular version of SQL Server 2012. Same with the control node, but the control node also has the ability to develop what are essentially query plans and knowledge of what the data that resides on all the compute nodes. So as this scales, as I indicated before, you can add scaled units. And again, these compute nodes, 4 and 3 in this case, just are 2 additional instances of SQL Server. And then 5 and 6, again, 2 more instances of SQL Server, and 8 and 7, 2 more instances of SQL Server with the appropriate JBOD storage attached to them. And then this yellow portion is for your ETL server, or your landing zone, as it's sometimes referred to. So no real complicated things going on there. At a basic level, it's something that if you're familiar with SMP and you remote into your compute node servers, you'll see that it's just a regular instance of SQL Server 2012. The table names and database names might, particularly the table names, will look a little funny because they'll probably have a hash value associated with them and things like that. And there's actually multiple distributions depending on the table you're looking at, whether or not it's replicated or distributed for that particular table, which I'll talk a little bit about. But just to give you an overview, a basic overview of what is actually behind the covers. Now for PDW, there's really no reason for you ever to actually remote into these servers and do any kind of work or poking around. All that is you can manage through the control node of the PDW. So it provides an interface for that. So here are just some of the details of the components within each one of these servers. It's a 1U type box with JBODs attached, and the other specifications on there. You can have a few different varieties of disks that you can have within the JBOD, depending on your size requirements. But what I really want to talk about, and kind of the whole purpose of this, is to talk a little bit about the query execution on the PDW. And because this is fundamental to understanding how to best utilize the PDW and its potential performance with your given data model. So here we have, again, a full rack of PDW with the base and the scale units, and then the control node where it says server there. So if we were to break this out a little bit differently, and look how queries are executed on this, what we would find is when a query is submitted, it is submitted, the connection string, IP address and name, those kind of things, are submitted to the control node. You don't submit queries directly to the base or the scale units. You submit it to the control node. And what happens is the control node has a few ways of knowing what data is where, and it'll actually take your single query and develop what's called a distributed query plan. So it will break down your single query into multiple queries that it then queries individually the underlying compute or processing nodes. And so those SQL Server instances will then receive their particular query generated by this control node and execute that query locally, and then return the results set back up to the control node, as indicated in this graphic. So that there's them returning it back. The control node then, in this case, only has to aggregate 4 result sets, assuming this is an aggregation, which is typical for data warehouse type workloads. It only has to combine those 4 result sets and then deliver the final result back to the requester, to the user. So that's the real magic of this is, or the real important part is that these is the important part of using the processing power of the PDWs to ensure that processing is occurring evenly on all 4, or in this case, or all of the scale units, so that none of these are left idle. They all get a query plan, and they all execute it, their portion of the data in parallel together, so that then the results can be combined up into the control node. So the way from a database and table DDL perspective, the way this should be thought about is that fundamentally, and this is kind of the difference between SMP and MPP, is that you have two types of tables you can create in PDW. You have what is called replicated and distributed tables. Replicated tables are tables that the table, a copy of each one is created on each of your compute nodes. So what that means in practical terms is when you execute one create table statement from your control node, because that's all you connect to, that actual create table statement is executed on each of the processing or compute nodes. For a distributed table, it's different. For a distributed table, you are actually able to create a portion of the distributed table's data on each of the nodes. And so what happens here is this is where the true power of the PDW comes into play. Now, as it says here, data is distributed with distributed tables based on the value of a single column. And the idea is to get uniformly distributed across all the nodes on the appliance. That is very important, because if one of the nodes, if you have skew going on, if let's say one of the nodes has significantly more data than the other nodes, then it's very likely that it will be doing most of the processing while the other ones sit relatively idle or do very little processing. And that way you're not harnessing the full parallel processing potential of the PDW. So picking what's referred to as your distribution column is very important, and making sure that there's no skew involved. And I'll get into this in a little bit more. And each distribution or each portion of that table's data exists on one of the nodes. So now I want to talk a little bit more in depth about this. So in terms of your database design, now what I have on the left hand side here is a typical star schema, fact and dimension tables. In my previous videos I haven't really talked too much about dimensional modeling, and I've just referenced Kimball and his architecture. And again, I'd highly recommend you read those books and get a thorough understanding, because the star schema architecture is the best way to get the best performance out of parallel data warehouse, and also out of a properly architected SMP solution as well, as I've described in previous videos. So what this means is that even if you start out at SMP and you have a star schema or several star schemas that you then, for performance and space reasons, need to move over into parallel data warehouse, you will not have to re-architect your entire data model just to make that happen. It'll be a very seamless transition, and you will see much better performance increases than if you had left your data in a more normalized format. Parallel data warehouse can accept any type of model that you create on it. You can create whatever tables you want. However, to get the best performance, it is very important and critical that you you follow dimensional modeling guidelines in creating star schemas. So now that I've clearly made that statement, now I want to continue forward. So if you're able to do that, create the star schemas, then this whole replicated and distributed thing becomes much simpler and will provide the best possible performance. And so how this works is I have represented here four of my processing nodes here. Four of those one base and 3 scale units that I talked about previously represented. And so what happens is your fact table, virtually all fact tables will be distributed, and then they'll be distributed on a column. And so when you do that, the data, a portion of the data, will go to each distribution. And in fact, on each compute node, there's multiple distributions, up 8 to be specific. But but for simplicity's sake, I'll just say a fourth of the data, ideally a fourth of the fact data would go here, a fourth of the fact data would go here, and here, and here, etc. So you get 100% of the data spread across all 4 of the nodes there. So that's your fact data. Then your dimensional data, that is the data that will be replicated. So each node will receive a copy of that table, the table and the data, a full copy of the table and the data, whereas your distributions are just a portion of the data from that table. So you might say to yourself, well, why is this? Well, because if you adhere to a star schema, if you think about processing, a typical data warehouse workload and query is that you join dimension keys to fact keys. And so the reason why you want to replicate your dimensional data is because you want to have local joins occurring on your nodes, meaning that all the data is local to the node. Whenever data has to travel, and it can travel from node to node to resolve the join or the query, that is inherently a much slower process than resolving those joins locally. So so that's why your dimension tables are replicated, to get the greatest speed possible for joins. Now your fact data is distributed because you want to make sure that that those joins occur as efficiently as possible against your fact data, and any aggregations occur local to each one of the nodes. I can briefly review the fact that PDW has Hadoop integration built into it, and so this can be a very good potential source of data as well, and analytics. And to wrap up this video, I'd like to finish with just the understanding of column store indexes. Now, I've produced a video about this. It goes much more detail about column store indexes, and I highly recommend those videos. But based on assuming that you've read those videos, now when I mention column store indexes, you will be able to understand why fact tables are the best way to get the maximum performance out of column store indexes. And as we've just seen from the PDW architecture, that again, star schemas are the best way to utilize those distributed tables, which will be your fact tables, because that is really where the parallelization of processing your data in parallel comes into play, and the full potential performance of the PDW can be maximized. It's through, again, that star schema, those fact tables. And so referencing also my first video, that those 3 elements that are so critical to to continued scalability and performance of your data warehouse, namely being your star schema, your balanced architecture, which can be either SMP for the fast-tracked appliances or MPP for parallel data warehouse. And lastly, the third important component is your column store indexes. And so now all three of those things combined together produce a scalable, reliable solution that will dramatically increase the ability of your data warehouse to scale and also its performance. Hopefully that has been helpful. Hopefully you've been able to understand a little bit more about the MPP appliance itself, Parallel Data Warehouse, and how by applying all the things you learned from SMP in my previous videos, you will get the maximum performance possible out of your MPP solution, your Parallel Data Warehouse solution. Thank you for your time.